differentiation. So basically what we've studied so far are derivatives of functions. Okay? So every x has one y value, right?
Yes.
Implicit differentiation is derivatives of curves that are not functions.
Oh, great.
Okay? So,
Can you take that test?
okay, this does not mean they're not fun, it just means they're not functions. Okay? So you'll see all sorts of crazy curves in your book if you look at them. Okay, one of the more prominent ones is a circle. A circle is not a function. So, let's start with something we know. I hope that's something you know. Okay.
I hope so.
So how would you answer that? What would you write on your paper? Word for word.
Y.
Okay, so we are asked to calculate that, so we would write y dx equals 2x, right? Okay. So technically, you just did what we're doing today. You just don't know it. Okay.
Wow.
So what is the derivative of y?
2x.
It's the derivative of y, the character y is 1. But since it's y, and we're differentiating with respect to x, we have to note that it's dy dx. Okay, and then of course x is 2x. We could technically, red flag, put this, the derivative of x with respect to x. Do we need to do that? No, because that's 1, right?
Yeah.
Okay, so we've been doing this kind of subconsciously with this notation right here. Okay.
Okay.
We could also write, if you really wanted to, you could write it like this, right?
Yeah.
That's just not what you're asked for. So implicit differentiation involves differentiating y's and x's in the same equation. Okay. Because we don't have a function. So let's look at a circle.
Yay, circles.
Okay. You remember the unit circle?
No.
You don't remember? That's bad. What's the radius of the unit circle?
1.
1. So what's the equation of the unit circle?
I don't know.
That's the area formula for a circle. I'm looking for how would I graph a circle? Okay. The center is 0, 0, correct?
Yes.
So we have no numbers with the x and y, and then the radius is 1 squared. Because that's the function is x minus h squared plus y minus 3 squared equals radius squared. So a little bit of a reminder from pre-calc.
Oh.
Center is hk, radius r.
Yeah.
Okay. The unit circle is the easiest of the bunch. We, in fact, about mid-October in pre-calculus, do an activity where we calculate the tangent line equations on the unit circle.
That's not good.
Okay. Can you derive that function with respect to x? So calculate dy dx.
So you just do everything like
Yes,
normal?
same thing. So what's the derivative of x squared?
2x.
Okay. 2y, this is where you have to tag that dy dx in there. So we have to put this here with it. Because we're deriving y with respect to x. So don't forget to put that. Equals what? Derivative of 1 is? Thank you. Somebody bells out. Okay. So the only addition here is that y is now in the equation, and we have to tag a dy dx on it when we derive it. Are we finished? This is calculate dy dx. Is that dy dx equals? No, it's not. So we have to solve that equation now. So it's an algebra problem at this point. And then what's our last step? How do I isolate dy dx? Well, we'll allow for that. So we have so the slope of any tangent line to a circle involves both x and y coordinates. It's not just based on the x value anymore. Okay, it's based on both the x and the y. Because we don't have a function. So just a very minor adjustment to what you've been doing already. So you could be asked for the slope of the tangent line at, that's not even a point on the unit circle. One zero. Plug it in. Yep. So dy dx. Remember your notation. Dy dx evaluated at 1, 0. Then how would you write the answer to that? What's that slope? It's undefined, right? Yeah, it is a vertical line. Questions? All right, some people prefer to write this as such. I really don't care what notation you use. Some people I like dy dx because that's how I learned it, and it's obvious. It's like, bam, right there I am. Some people like y prime because they're lazy and they like to write it faster. I don't care what you think. Okay, you can use the second notation if you'd like. I'm pretty sure your book has both of them. Right, so it does not matter how you write this, either way. Just pick one. Okay. Oh, let's see. Step it up a bit. As always, we can implement product rule, chain rule, etc., etc., etc. in these problems. Right, so
Catch it. Oh, no, they're close.
what rule do we have here? Yeah, that's a product. And this is a,
No, the.
Power rule.
What's going on? What's it do?
wake up! So, what's the product rule? Luis? Ready, set, go.
You're going formula like F
Yeah.
prime, or F, how would you say it?
You were started off pretty good.
Oh, is that how you say it? F
Yeah,
prime?
that's fine.
F prime G, or,
Okay, so derive f prime, right?
yeah,
Which is 1. Copy
Y,
plus,
copy, right, 1,
and what do I include with the derivative of y?
the dx over dy.
Yeah. So every time you derive y. Okay, and then what's that?
6x.
Did you derive that equation? Do we need to simplify it? No, you don't. At this point.
So you can just leave it like that?
Yeah, just answer the question, right? Did you derive it? Yeah. Okay, but the first one didn't say calculate dy dx, that's what you need to calculate. Right?
Oh,
So, yeah, there's, mathematics is nice because it's really specific. The question is, at the level that you're at, it's very specific. Just answer the question, that's all you gotta do. So, so sometimes you're not given a y value. So if you evaluate the derivative at x equals 1, how can you find the y value? Yeah, so we gotta plug 1 into the original, right? What does y equal? 3. So really this is 1, 3. So sometimes you're only given the x value and you have to calculate the y value. If x is 1, plug 1 in, so you get 1y equals 3. Divided, right? Y equals 3. And if you're asked to evaluate one of these, it is easier to plug your numbers in at this point. So I can plug 3 in. Okay, that's perfectly legitimate. You don't have to solve it algebraically first. It's a little hint, okay? So the dy dx is? Right? You following? Can you write the equation of the tangent line at this point? Okay, go. Write it, and then you'll check your answer with mine. I'll give you 30
Can you pass me the
seconds.
marker?
Good. How do you write the equation of the line? Yeah. What do you put where? Okay, what's the problem? You're good. Yeah. Okay, there you go.
That's right.
Okay. You might also be asked to calculate. There are 10 free responses that we're gonna work on heavily for the AP exam. Like 10 different formatted free responses. One of those is something like this. Okay, so you might be asked to calculate the derivative, but also the second derivative.
Great.
That does require that you solve the first derivative for dy dx first. Okay, so sometimes it gets you anyways. So dy dx is subtract y and divide by x, correct? So 6x minus y over x. Come on. So second derivative, Asa, what rule is that? See a fraction, what rule? Quotient rule. So you have a quotient rule here. So these do get a little bit large. Okay, just go step by step. Low. What's the next? D high. All right, so 6 minus dy dx. You just derived y minus high d low over square root of low. Yeah.
That's
Yeah. Whatever. Crap? Oh, crap. So didn't hear that right. It's very, that's a 2-pointer on a free response.
right.
Okay, so it's big bonus points, so if you know how to do it, you're gonna earn a lot of points on these if you know how to do it. You might also be asked, this is a very popular, to evaluate at the same point that you were in the first part. Clock off.
Yes.
Homework is supposed to on Google Classroom. So if you
Yeah, it is actually.
plug things in and check, but you got dy dx's value for in there as well. I'm sorry.
A lot on No, that one was.
Elizabeth, is this CO to the office?
See you later.
Not coming to you.